Good morning, good afternoon, or good night, everyone. My name is Sarah Tusanya, and I am one of the team member of this team research. And here I want to represent our research with title COVID-19 Pandemic Effect on Earthquake Seismic Data in Indonesia. And now I want to start with the introductions of this research. COVID-19 stands for Coronavirus Disease 2019. This virus firstly appears and infected humans in Wuhan, China. Because of human habit and mobility, this virus has widely spread around the world. According to the Worldometer as of July 2020, that there is 210 countries and territories around the world that are affected by this virus. World Health Organization released some protocols to against this virus, and Indonesia makes work from home compulsory for everyone. The effect of this policy makes the world quiet and brings another impact for seismic data. While the world becomes quiet, the seismologists found a fact that the seismograph can record the seismic wave well. Seismology is a study of propagation of elastic waves through the mostly solid media, and the seismic waves result from the natural or man-made. We can find seismic noise on seismograms. Seismic noise is a baseline vibration in the crust that can be resulted from the transportation network or another human activities. The noise from human activities can reduce the ability of seismologists to detect another signal that occurs at the same frequencies. And this paper aims to know the COVID-19 pandemic effect on earthquake seismic data based on real seismograms. Now let's move to the methods. There are some methods to prove it. The first step is plotting total cases in Indonesia. Here we use the data from our word in data in CSV format, and we use the pandas and matplotlib to plot the total cases in Indonesia. And the second step is downloading real seismograms. Firstly, we have to go to this link and we can choose the date, magnitude, location, event, and station. Here we use the Java event and we use the Kalbi station. Kalbi station located on Kapang, Sulawesi, Indonesia. And for the sample, we use the data for 23rd February, 14 March, 25th April, and 12th May. And the third step is the reading and filtering seismic data. We use WinQuake to read and filtering the data. For the research, we use FFT bandpass filter to filter the seismic data, and we use the notch filter to show the noises. And the last step is comparing the seismograms and analyzing the correlation. From the results of plots of real seismograms and its filtering, we found the differences, and then we analyzed it to get the correlation between them. Now let's move to the result. Below is the plot of coronavirus total cases in Indonesia, real seismogram, and the filtered seismic data. And now we can see the total cases in Indonesia. For the x-axis is the date, and for the y-axis is for the total cases. We can see from the graph if the total cases in Indonesia is increasing day by day. And then we move to the real seismic data before work from home that we can see on the figure 3. On the figure 4, we can see the real seismic data during work from home. For the figure 5, we can see the filtered seismic data before work from home. On figure 6, we can see the filtered seismic data during work from home. On the figure 7, we can see the noise of seismic data before work from home. And on the figure 8, we can see the noise of seismic data during work from home. And now let's do the discussions. On figure 3, we can see real seismogram before pandemic more crowded than real seismogram during work from home, because there is a restriction for outdoor activities and it makes traffic lowering. And so seismographs can record data much better than before, and the seismologists can use it for disaster mitigation. Here, we use bandpass filter to remove higher and lower frequencies from a signal data at the same time. On figure 5 and 6, we can be seen that the four images look similar after filtering and look much clearer, because the noises has disappeared. But on figure 7 and on figure 8, we can see the noises before and during work from home is different. By this seismic data, we can calculate the RMS, that is a root mean square. This data show that the RMS during work from home is lower than before this pandemic, and the RMS becomes lower after filtering using bandpass filter. And now let's move to the conclusions. From the total cases in Indonesia, real seismic data, and the filtered seismic data, we can conclude that one of the effects of this outbreak is traffic much quieter and it affected seismic data in Indonesia. The seismic data before and during work from home is different, while the during work from home, the ambient noise is getting quieter than before. Okay, thanks for your attention. Thank you.